Question number 1. Select the unique product that is present in the incomplete combustion of an alkane. The answer is B, carbon monoxide, CO. Carbon dioxide is formed from complete combustion. Question number 2. Balance the following combustion reaction with the smallest possible whole numbers by filling in each blank with the proper coefficient. The coefficient is 1, fill in 1. So this problem, propane, is C3H8. So we have to remember those alkanes. So C3H8 is the formula for that. Plus oxygen reacts with water, or to form water. Carbon dioxide, CO2. Carbon, the reactant side, you have 3 carbons, 8 hydrogens, and 2 oxygen atoms. The product side, you've got 1 carbon, 2 hydrogen atoms, 3 oxygen atoms. I'll start with balancing carbon. 3 carbons changes the number of oxygen atoms to 7. 3 times 2 is 6, plus 1 is 7. So carbons are balanced. Hydrogens, moving on. Put a 4 there. 4 times 2 is 8. It's going to change the number of oxygen atoms again. 4 times 1 is 4. 3 times 2 is 6. 4 plus 6 is 10. So now the oxygens are out of balance. Need 10 on the reactant side. 5 times 2 is 10. That equation is balanced. So to answer the question, you would have 1 mole of propane reacting with 5 moles of oxygen, making 4 moles of water and 3 moles of carbon dioxide to balance that. So 1, 1, 5, 5, 4, 4, 3, 3. Question number 3. Which compound below will have the lowest boiling point? The answer is B. Well, got 1, 2 carbons, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It has the least amount of carbon atoms in it. The rules with alkanes is in general the smaller the alkane, the lower the boiling point. If you were comparing A and D, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, they have the same number of carbons, but A would have a lower boiling point because there's less surface area. Less of it's exposed. So more of the molecule is open. Question number 4. Select the 2 molecules that are constitutional isomers. You must select the 2 correct molecules to get credit for the problem. So if you get one of them, that doesn't matter. You've got to get both. So to do this, 1, 2, 3, 4, 5, 6 carbons. One, 2, 3, 4, 5, 6 carbons. I'm just going to systematically count them. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, 7. So we can rule E out. Because in order to even be isomers of any kind, you have to have the same formula. The 4 options on the left have 6 carbons, no double bonds, no rings, so they have the same formula. And if you go and you name them, 1, 2 methyl, 1, 2, 3 methyl. Okay, so these 2 have different names. So they're going to fit the constitutional isomer definition. If you look at the others, 1, 2 methyl, 1, 2, 3, 4, 5. Again, and this is 2 methyl. So these 2 are identical molecules. These 3, in fact, are identical. Okay, just different conformations. This molecule, you've seen it's flipped over like you would flip over a pancake. Flip from that flip. And then this molecule is changed, has a different conformation, but it's still 2-methyl pentane. 1, 2, 3, 4, 5, yeah, 2-methyl pentane. Question number 3, name the compound. So it's a cycloalkene. So that means 1, 2, or 1, 2. 2 options. 1, 2, or 1, 2. For cyclic alkenes, the double bond has to be 1 and 2. And then next, you minimize the location. You've got a substituent here on the double bond. Well, 1's as low as you can order it. So the scheme in black is the one that makes sense to use. You've got a methyl group on carbon 1, 3, continue numbering. So you've got methyl groups on 1 and 6. Therefore the answer is B. 1,6-dimethyl cyclohexene for the name. Question number 6. Select the molecule that does not have cis-trans isomers. For this problem, it's useful to draw out the to expand the condensed formulas. So this has got 1, 2, 3, 4, 5 carbons in it. And just for translating it, 1, 2, 3, 4. So you've got a double bond. 1, 2, 3, 4, 5. 1, 2, 3. So after the third carbon, you've got a double bond. This isn't for naming, this is just to quickly convert this into a skeletal structure. Well, you see this. Implied hydrogen there, implied hydrogen there. The way that I've drawn that, that's trans, so can't be that. Next. So 2 ethyl groups bonded to this carbon. So 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6. Drew one too many. Let me erase it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3. 1, 2, 3. That's got the other ethyl group on it. Okay, so 1, 2, 1, 2. That's that condensed formula. And then on the other side, we've got a methyl and a hydrogen. So if I look at that, this does not have cis-trans isomers because you've got 2 identical groups on the same end. This next example, you've got a CH3, a hydrogen, a CH3. So this end of the double bond has hydrogens on a methyl and vice versa. Hydrogens on a methyl and vice versa. So it wouldn't have been C. And then this other one, you've got carbon with a hydrogen and an ethyl group. Would be on if you expanded that out. Then a methyl group and a hydrogen. So 2 unique groups, 2 unique groups. So in hindsight, a quicker way to do that. So you've got 2 identical groups on this carbon from the condensed formula. Question number 7. Which reagent is necessary for the transformation? The answer is B, H2 and palladium, or it could have been platinum or another metal, but the change was there's 1 implied hydrogen atom here, no implied hydrogen atom there. Here, there's 1 implied hydrogen atom, 2 implied hydrogen atoms. Hydrogen was added. It's a hydrogenation. Question number 8. Consider the reaction below and select the true statement. So, if we look at, so the answers say all of them have Markovnikov's rule as part of them. So Markovnikov's rule is that the hydrogen atom in the starting material, or excuse me, the carbon atom in the starting material that has the most hydrogen atoms gets hydrogen richer. So the bottom carbon, where I've drawn the hydrogen, that's the hydrogen-rich carbon. Yet in the product, the hydrogen from HBr was added to the carbon that is less hydrogen-rich. Okay, so this product doesn't obey Markovnikov's rule. The hydrogen went in the wrong place. If it had obeyed it, that would be the product, if it obeyed Markovnikov's rule. So the answer is B. The product is incorrect because it does not follow Markovnikov's rule. Question number 9. To which carbon atom will the hydroxyl group add in the major product in the addition reaction below? So the carbons of interest are here. That's where the alkene is, so it's got to be either 5 or 6. But then, so the hydroxyl group, the hydrogen atom where it would add first, or where it would add, carbon number 5 has 1 implied hydrogen, carbon number 6 has none. So the hydrogen would add to 5. Therefore, the hydroxyl would add to carbon number 6. And drawing the product. The hydroxyl would add to number 6. Carbon number 5 got hydrogen richer. Question number 10. Which fatty acid will have the highest melting point? The answer is D. Well, it's saturated. The alkyl chain, the carbon chain. There are no double bonds. You've got one, this is mono unsaturated. These two are polyunsaturated. Okay, multiple double bonds. This molecule and this molecule, the way they're drawn, these are trans fats. They're trans alkenes, not alkenes, fatty acids, but they would have similar properties, but where there are no double bonds here, this is what you would predict to have the highest melting point. Question number 11. The process of hydrogenating vegetable oil to make margarine produces trans fat. Which statement is true about trans fat? The answer is B. Trans fats have similar properties compared to saturated fats. So in question number 10, you can see structurally they look similar to a saturated fat, and it's true that nutritionists limit the intake of both trans and saturated fats. They have a tendency to be more solid at room temperature, and it means there'll be solids in general, and they're more likely to be clogs in arteries and veins. Question number 12. What monomer is used to synthesize the polymer below? Scroll down to see the entire structure. So, if you identify the monomer, you look for the repeating unit, and here it is. Okay, CH2, CH3, a carbon's there, carbonyl, OCH3. So this is an ester. Then repeats again. So I draw that. Just redraw it to the side. I'm using bond line, just because the answers are formatted that way. And then the double bond, that's where the polymerization took place. So that's what the monomer looks like. So just draw it first, and then the answer is D. If you draw it first, that'll make it a little bit easier to sort through your choices. Question number 13. Which option is needed to accomplish the following transformation? The answer is B, chlorine in the presence of iron 3 chloride. So this is an aromatic compound. Aromatic compounds require a catalyst in order for the substitution to take place. You think that these electrons are going around and around and around. You have to have a catalyst to get them to stop, so to speak, for a chemical reaction to occur. Question number 14. Classify each indicated alcohol as either primary, secondary, or tertiary. So this alcohol is bonded to 1, 2, 3 carbon atoms. Therefore, it is tertiary. Two, 1, 2 carbons. Secondary. Then lastly, that carbon is bonded to 1 carbon directly to primary. Question number 10. What is the IUPAC or IUPAC name for the molecule below? So with alcohols, is what this is. You minimize the location of the hydroxyl group. So 1, 2, 3 versus 1, 2, 3, 4. Okay. 3 is lower than 4. So 1, 2, 3, 4, 5, 6. So 3-hexanol is going to be the parent, and that's going to be B. The methyl group's on carbon 5. Question number 16. What is the major organic product of the reaction below? For this type of problem, it's good to draw both possibilities. So the alcohol's here. That means the double bond's going to form to the left or to the right. That's your only two choices, left or right. That's it. And then whichever one's more substituted is going to be the major product. So if you draw the applied hydrogen atoms, so that double bond, there's 2 hydrogens there, a carbon here and a carbon here. So this point, this point, this point, and this point. This is di-substituted. Look at the next candidate. Carbon, 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 only 1 hydrogen. This is tri-substituted. So I go looking for that structure. The answer is A. The more substituted alkene forms during a dehydration reaction. Question number 17. What is the oxidation product of a secondary alcohol with potassium dichromate? So for this type of problem, just draw a secondary alcohol, any secondary alcohol of your choice. So that's secondary, 1, 2 carbons. Are bonded to the carbon, bonded to the oxygen. That's a lot of connections, but that's secondary. It has 1 implied hydrogen atom, so it can only undergo oxidation once. That would be the oxidation product. That's a ketone. Question number 18. Name the molecule below using IUPAC rules, IUPAC rules. For example, using this scheme. So dashes separate numbers and letters. Okay, dash, number, letter. So the name of this molecule, we've got 1, 2, 3, 1, 2. So 3 is bigger, it's the longer chain. So this is your substituent. So this would be 1-ethoxy. Remember, for ethers, this whole group, so 1, 2 carbons is an ethyl group, but an oxygen is there. So ethoxy. 1, 2, 3. The ethoxy group is on carbon number 1, propane. So 1, 2, 3. Question number 12. The reactions below illustrate how hair is curled. You've got disulfide bridges are broken, then regenerated in the hair curling process. Which statement describes the reaction steps? Step 1, the sulfurs gain hydrogens. Step 1 is a reduction. Step 2, the sulfurs lose the hydrogens. So step 2 is an oxidation. So looking at that, the answer's A. The bridge is reduced. Step 2, the thiols are oxidized. C, there's your options reduced, reduced. So the reason C's incorrect or tricky. So these are disulfide bridges. These are thiols. So a thiol is alcohol-like, but instead of oxygen, you have sulfur. So pay attention. These are disulfides. Okay, in the name, di for 2. And then here's the thiols. Question number 20. Rank the following molecules according to boiling point. Enter the names of the compound with the lowest and the highest boiling points. So for this type of problem, you have to know what the characteristic or the strongest intermolecular force possible is with each choice. Choice 1 is an ether, and it has polar bonds, but there's no oxygen-hydrogen bond. So this is dipole-dipole, possible. Propane, no heteroatoms, no any, so that's London forces only. Okay, the weakest. And then isopropyl, or isopropyl alcohol, or isopropanol, 2-isopropanol, can hydrogen bond. Isopropyl alcohol's got the strongest intermolecular force, so the highest is isopropanol. And then the weakest is going to be propane, the lowest boiling point, because it has the weaker intermolecular forces. Dimethyl ether would be in the middle somewhere. Question 21. Similar as the previous one, but rank the following molecules according to boiling point. Enter the name of the compound with the lowest and the highest boiling points. So the numbers got skewed here, the names got skewed a little bit. Acetone, isopropanol, acetic acid. So for this, it's looking at the intermolecular forces again. Acetone has dipole-dipole. So you've got a polar bond here, but there's no oxygen-hydrogen bond. Case here. The alcohol can hydrogen bond. A hydrogen covalently bonded to oxygen. And then with the carboxylic acid below, it's got hydrogen bonding. There. So similar to the alcohol. But right next door is a carbonyl. So it has hydrogen bonding and dipole-dipole. So acetic acid would have your highest boiling point, and the lowest would be acetone among those three.